Hello everybody, welcome to the next video. This video is about use of calculator for a simple iteration method that is also known as fixed point method. In this lecture, my focus will be on development or use of calculator in solution of nonlinear algebraic or transcendental equations by simple iteration method. So let me first discuss the main steps used in the development of fixed point method. Let's suppose we want to solve an equation f of x equal to 0 which has a root near to this number x naught. Or we might be given an interval that the equation has a root in the interval a b. Okay, so the first step is we solve this equation f of x equal to 0 in the form of x is equal to g of x, which basically means you would leave everything to the left side and to the right side and leave x, only x on the left side, right? And then we would check whether these iterations, after setting the iterations, whether they are converging or not. So for that purpose, the condition is words that initial condition or initial value of x naught, we would be checking whether g dash x naught absolute is less than 1. If this is less than 1 for a certain representation, because you can have different type of representation for a one equation f of x equal to 0, that's x equal to g of x. So there might be some function g of x with different initial values. It might be converging or they might not be converging. They might be diverging. So if the condition is satisfied, g dash x naught absolute, if that is less than 1, the iterations we are setting in a while, that would be convergent. If this is greater than or equal to 1, the iterations would be divergent then. Once you came to know that the iteration they will be convergent, so we set the following iterations then, that is xn plus 1, that is equal to g of x, n for different values of n, that's starting from 0, 1, 2, 3, and so on, unless we have a specified accuracy of a root. In this case, how does it work? You will simply put the value of x naught, which will be given in the right hand side of this equation. That would give you x1. Then we would put that x1 in this equation to get x2. Then we find x3 and so on. And then we check the convergence, whether it is converging to a specific root or not, with a certain decimal place, a certain accuracy of a decimal places. Okay, so let me discuss the example first, and then I'll use calculator to do those steps. So let's suppose we want to solve this transcendental equation 2x minus 3 is equal to cos x. You can take any example. And this equation has a root in the interval 3 by 2 and pi by 2. Yeah, you can take anything. You can take a one value as well, that this equation has a root near, let's suppose 3 by 2, or we say its root is near pi by 2, or anything between these two numbers. So this equation, the first step is would be solved for x. That is, we need to write the equation in the form x is equal to something, and there are many operations. You can say many representation. We can simply take x is equal to cos inverse 2x minus 3. We can take x is equal to cos x plus 3 divided by 2, which we are taking here. We are using that. So x is equal to 1 by 2 cos x plus 3. And in this case, obviously, g of x would be 1 over 2 cos x plus 3. And if you differentiate this function, its derivative would be minus 1 by 2 sine x, but we take absolute of it, so we get 1 by 2 sine x absolute. And you know the value of sine x is always less than 1. Dividing by 2 is also less than 1. Absolute value of sine x is always less than 1. So in this interval, at every point, this derivative would be less than 1. Right, it means if you set up the iterations will be converging to a specific root of this equation. So let's suppose we choose x not equal to 1.5. You can take any number, any real number in this interval, 3 by 2 to pi by 2. We can take pi by 2 as well. We can take 3 by 2. We have taken 3 by 2. And then we set the following iterations. Xn plus 1 would be 1 by 2 cos xn plus 3. Just replacing x in this equation, x in the left side with xn plus 1. That's the new value, whereas this x would be replaced with the old value, right, where n is equal to 0, 1, 2, 3, 4, and so on. So let's start with n equal to 1, 0. So if we take n equal to 0, what happens? We will get x1 here, that is 1 by 2 cos x naught plus 3. And we have chosen x naught to be 1.5, so just replace 1.5. So cos 1.5 and then plus 3 dividing by 2 would give you 1.5354. Similarly, now using this value 1.5354, because x2 would be 1 by 2 cos x1 plus 3, where x1 is 1.5354. So you would use this value here plus 3, and that is 1.5177. Then using this 1.5177 here and finding x3, that is 1.5265, using this value for x4, right? That's 1.5221, and then repeating this process, we would find x5, x6, and x7. So the x7 is correct up to 3dp if you want to have a solution up to 3dp. If you want to increase the number of decimal places, so obviously we'll be doing more iterations, right? So how do we do that by using calculator? Let me do that, explain that for you. So again, as I said earlier in the last videos, previous videos, you need to have uh, a setup or a mode. So you should go for 1 because that must be in math mode, and the mode of calculator must be in radians. Okay. Now, what would you do? You simply type this equation here. Let's see. I'll go for alpha and then simply put x. Then I'll put equal, and then we have this function, whatever you can simply write 0.5 times into cos of x. So we have cos, then we will be having x here back, and then we close the bracket, and then plus 3. And closing the bracket. Okay, it's a very simple thing. In a fixed point, simply take x is equal to 1 by 2 cos x plus 3. So if we have done that, you have typed these quantities, so you simply press this calc, and it would ask about the initial value. Okay, so you would simply give 1.5. So I just give 1.5 to it. So when I press equal, I would get the first value. That is 1.53536 and something like that. Next time, you don't need to do anything. Simply press this equal button. So if you press equal button once, you do that again. Okay, so you'll get 1.5177, 10158, and so on. Next time you press equal, you will give the same value to x, and then you press equal again to get the next value, 1.5265306119. You can increase the number of significant figures as well. You press it again to get another value. You see, that's the value of x. And then you see we will be getting this value 1.5221. You press equal 1, that is asking for x, which you don't need to change. It takes the updated value, and then you press x. The new value is 1.5243. Then we go for another one, another equal, so you get 1.52322 now. And then for the next value, that's the 7th iteration, which would give you 1.52377, something like that. So if you look at the values, these 523, they are repeating again and again. If you press equal, you would see that these 3 digits are repeating, 3 decimal places repeating. We can get a result up to even though 9 decimal places. I just press this button again and again, I'll be getting improved result. You see the iteration will be converging. So we have 1.5236. Next time we'll be getting 5235. If you stop at 4th iteration, you see that will become 6. So next time it will be simply 5236. Then it will remain 5235, something like that. So it is converging to this root 5.236 and so on. So I hope you understood that, and you should practice this. Thank you very much. See you in next video.